All right, final video of section 9.1, or I hope to be the final video. Hopefully, coming off of video part 3, we know how to use sine, cosine, tangent to find missing sides and angles. So let's finish this thing up. You are hiking near a canyon while standing at A. So if you can't read this very well, you're standing here. You measure an angle 90 degrees to B, 90 degrees to C, which means I should change color that I can see. We've got 90-degree right here, so basically justifying a right triangle. You then walk to B and measure an angle of 76 degrees between A and C. So again, 76 degrees right there in our triangle. Distance between A and B is about 2 miles. How wide is the canyon between A and C? So if we put an X there. From the last video, we'd be looking at from 76 that this is the adjacent side and this is the hypotenuse. So that would scream cosine because of the ka, so ka, toa. So we'd be writing cosine of 76 degrees equals 2 over x. Go to my calculator, do the cosine of 76, and get 0.2419, 2 over x. Multiply both sides by x to get it off the bottom. Do 2 divided by the decimal and get something like 8.267 is our distance. All right. Okay, these last few problems these next two problems are not necessarily anything different, but it is a little bit different vocabulary. Angle of depression, angle of elevation. So really, when we overuse this, you might not be familiar with it, but imagine you have this building. Draw a door here. Imagine we have this building, and what we do is we imagine going straight out, an imaginary line parallel with the ground, parallel with the sky, these two black lines. Then what we do is we put a diagonal in here. So what you can kind of see is the right triangle formulating inside of this rectangle. So you can kind of, hopefully you're seeing that right triangle or that right triangle. What is described as the angle of elevation would be, this angle right here would be the angle of elevation. We are elevating from the ground. So it's the angle under what ends up being the hypotenuse, the angle formed by the hypotenuse in the ground. The angle up here that is actually an alternate interior angle, just trying to throw back some old school vocabulary for you, is known as the angle of depression. More often than not, we get these problems, angles of elevation, and come to terms with something elevating from the ground. Angles of depression, the most I've usually seen is from something flying in the sky and referencing downward, though there could be others. Parasailer is attached to a boat with a rope 72 feet long. The angle of elevation from the boat to the parasailer. So if we got our boat, I'm on a boat with my flippy floppies. Anybody ever been parasailing? Little line, somebody's up here floating in the air on top of the world like the Carpenters. I'm on the top of the world. Okay, that's a 72-foot long rope, it says. If we come straight out from here, it tells me angle of elevation is 28. So you need to be able to read that and know that the 28 is there. Estimate the parasailer's height above the boat. So that's our setup from all that, which is really the real challenge for you here. This is the side opposite of 28, and this is still the hypotenuse. So that implies so. Then we go sine of 28 equals x over 72. If I get sine of 28 and then multiply it by 72, looks like I'm going to get something like 33.8 feet high in the air from the deck of the boat. You're measuring the height of a spruce tree. High tree, put a tree up. You stand 45 feet from the base of the tree. 45. Measure the angle of elevation. Why would anybody do that? I don't know, but here we are in math class. 59 degrees. Find the height, h. So I see adjacent, I see opposite of 59, so that to me is screaming TOA. Tan of 59 equals opposite over adjacent. So if I go tan of 59 in my calculator, multiply it by 45, I get something like 74.89 feet high. All right, let's finish up by looking at this challenge. Find the perimeter. So we need to end up solving for all the sides. Let's put in some information here. AC is 26. AD is equal to BF. We're going to need that later. We won't be able to find some things out. So AD is equal to BF. D is the midpoint of AC. So that means it's perfectly splitting. So all three of those sides are equal. That's fun. Let's get started. First thing I'm looking at is, I think, triangle ABC, because it's the only one with the side length there of 26. But in the meantime, might as well also write that this is 13. This is 13 because it's perfectly split of 26, and this is 13. That being said, I want to find this side. So if this 26 is adjacent and this x is opposite of 35, I'm going to go tan of 35 equals adjacent or opposite over adjacent. So I go tan of 35 times 26. I get something like, we're just going to go a single decimal place because I imagine this is going to get messy. So 4.2. So from here to here is 4.2. Already too messy. .2 is the first part of my thing. We also figured out that this was 13 before, even though you just saw me erase it. Sure, let's do another one. Let's see what, and this is 13. Well, if I know that's 13, then I'm going to solve for AE. And then I'm going to, so for AE, I'm going to say sine of 50 equals 13 over AE. So sine of 50. Got to multiply the x over, so you got 766 AE equals 13. Divide the decimal and get something like 16.97. So I'm going to call it 16.97. I'm going to do the same thing for ED, except now I got to use cosine because ED is or tan, opposite over adjacent. So if I go tan of 50, opposite side is 13, adjacent side is ED. I go tan of 50, multiply the ED over here, divide off the decimal. All right, so we're starting to fill up. Let's see, what else do we need to know? need to know some angle measures is what it seems like. So if I go to blue here, looking at triangle ABC, if I do 180 degrees in a triangle, minus 35 degrees, minus 90 degrees, then I know that this has to be 55. These little markers in here, if you remember from geometry, mean that they're all equal. So I can do that. Now it looks like I can start doing some things to get GF, to get BH, to get FH. So that being said, let's get to work. For GF, if I go opposite, so if I go tan of 55 equals opposite, which is GF over 13. So I'm looking at triangle BGF to set up this problem. If I go tan of 55 times 13, 18.57. Okay, now if I want to look at side FH, I'm going to look at triangle BHF or BFH, and I'm going to look opposite, because here's 90 degree, right? So I'm going to look at an adjacent side and an opposite, so I'm going to go tan of 55 again equals opposite, so FH over adjacent, which is this 13. So tan of 55 divided by 13 is the same as before, right? So we also got 18.57. Fancy that. Now if I go BH, and I want to say cosine of 55 equals adjacent over hypotenuse, looking at triangle BHF. So if I go cosine of 55, multiply the BH over, and then divide the decimal off, I think I get something like 22.66. Now the only one I haven't found yet, but I see how I'm going to, right, is if any of you else are with me here, I need to find GC. So I don't have any one, it's a two-step process to get there, right? First thing I'm going to do is find BG from triangle BFG. So I'm going to do adjacent 13, so cosine of 55 adjacent over hypotenuse. So cosine of 55 multiply BG over 13 divided by decimal. .66. So I know this little portion is 22.66, which now tells me if I'm looking at triangle ACB or ABC, so that I really want to find all of BC, and then I'm going to do a subtraction problem. So I'm going to go back to the original ACB and 26, and that's adjacent over hypotenuse. I'm going to go cosine of 35. The adjacent side is 26. The whole hypotenuse is what I'm looking for. So I'm going to go cosine of 35, multiply the BC over 26 divided by the decimal, and I'm going to get something like a total length of, then to find just CG, I'm going to do 22, or I'm going to do 31.74 minus 22.66, so 31.74. So CG must be 9.08. Now it should be time for me to start adding amongst all these numbers. So 16.97 plus that said 15.44 plus 13 plus 9.08 plus 18.57 plus 18.57 plus 22.66 plus 4.2. Then the perimeter looks to be 118.49. All right. If you could follow most of that along, I'm pretty happy. That was a nice little stretch of old geometry view, stuff that's going to serve us well the rest of the chapter.